In the last episode we have learned how to load tiled maps in Arcade, and we have used this industrial.tmx file. And what I haven't told you that you can also use JSON file format for loading tiled maps. So this is where we left off. We have the platforms, we have these terminals, we have this saw, rotating saw, and a greeny character. And now what we are going to do is move the greeny character left, right, up and down. We are just going to add a very simple movement without any physics or without any collision detections. And as the green character will move, we are going to add the camera, and the camera will follow smoothly the greeny character. So first let's add some movement to greeny. And for this I'm just going to create 4 properties here in the init method of the GameView class. And this will be the directions, and left, right, up, down will be all set to false, so these are booleans. Here I'm going to set greeny speed to 500 and greeny's XY position to 100 and 200. And I'm just going to exchange this greeny sprite position to greeny X and also greeny Y. And now let's add also the event handler for the on-key press and also for the on-key release event. And because I already showed you this, I'm just going to copy and paste the whole code for this here on line 37. So this will be the on-key press, and if the symbol is left, we are going to set directions at left to true, and also if right, directions at right to true, and up and down the same. So we are just going to switch these to trues. And we should also switch back these to falses if we release the key or the keys. So on key release, if we release the left key, we are going to set back the directions at left to false, and this applies to right, up, and also to down. And now here in the on update, we are going to move greeny. So if set the directions at left is true, we are going to set greeny's X position equal to set.greeny speed times the delta time. And this also applies. If right is true, then we are going to add to greeny's X position, and if up is true, we are going to add to greeny's Y position, and if down is true, we are going to subtract from greeny's Y position. And here we are going to set the greeny sprite position. So cell.greeny underscore sprite position equals cell.greeny X and greeny Y. And now we are able to move greeny right, left, up and down. The one more thing I'm just going to add is when greeny moves to left, he will face to left. So just set the X scale based on the direction. So here in the on key press event, if the left key is pressed, we are going to set the greeny sprite that scale X equal to -1. And if the right key is pressed, we are going to set it to +1. So greeny sprite that scale X equals 1. And now let me try it. And now if greeny moves left, he faces left, right, left. So this is how you can set the facing. Okay, it's time to do the camera stuff. So in Arcade you have the camera class. You can create 2D cameras using the following command. So I'm just going to call it self.camera and arcade.camera.camera2D. And you can read about the camera 2D and its properties and functionalities in the documentation. So the next thing what we have to do is tell Arcade that we are going to use this camera. So in the onDraw method, in every draw call, before the clear, I'm just going to call the self.camera.use. And this has to be called in every draw call. And here in the on update method, I'm just going to set the camera's position based on greeny's position, using the following command. So cell.camera.position equals cell.greenyx and cell.greeny. So let me try this. And as you can see now, greeny is in the center of the window, and also this platform is a little bit offsetted. And now as I move greeny, the camera moves with it. But it still not follows it smoothly, it just follows it immediately. And one more thing I'm just going to set is that greeny is always before the other sprites. So the draw order matters. Here, let's go to the on draw, and here is the greenish sprite list. I'm just going to move this line on the bottom. So now it will draw greeny on top of every other sprite, as you can see. Okay, now let's add smooth camera follow, because this doesn't look very nice. So what I'm going to do is, in the onUpdate method, I'm just going to comment out this line and later also delete this line. And I'm going to create a new method here. And this will be called pan camera to player. So this will make the camera pan always to the player position smoothly. I'm just going to add here so-called panning fraction. I'm just going to show you later how it changes the panning. And I'm added this mini documentation, so manage scrolling, and this is from the arcade docs. So I found these in the arcade docs. And two more things I'm going to create, but these will be global constants. I'm just going to create these two variables, or these two constants. One will be the camera pan speed. I'm just going to set it to 0.3, and the grid pixel size, which will be set to 70. And 70 because in the previous video I already showed you that each of those tiles are 70 by 70. Okay, now let's go back to the pan camera to player, and here I'm just going to set the camera's position to this function. So arcade.mat.smurp2d, and let me hover over with the mouse, and it smoothly interpolates between two sequences of length 2 independent of time, blah 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 blah. So just read about this. So it takes value 1, value 2, or a vector 2s, and the delta time, and also this h. So let me see the first value to interpolate from. This is the v1, v2 the second value to interpolate to, dt is the time in seconds that has passed since v1 was interpolated last, and the h the decay constant. The lower the faster v1 reaches v2. So we are going to use this smurp, or smooth interpolation function. And the first value will be the camera position. So this will be the from, and the 2 will be of course the greenish position, so cell.greeny.position, and the delta time we are just going to, so dt will be the cell.window.delta time. We can get the delta time with this line, so window.delta time, so which is 1/60, and the last value is the decay constant, and for this I'm just going to use the panning fraction, which is passed here, so that its initial value, or its default value, is set to 1. Okay, now let's call this pan camera to player function inside the onUpdate method. So self.pan camera to player, and let me try this out. Okay, now as you can see how the camera, it slowly goes towards, so the center of the camera slowly goes towards greeny, and as it moves, it just slowly follows greeny. So this value of 1 is a little bit high, so that's why I have created here this constant, this camera pan speed, and I'm just going to use this, which is set to 0.3. And here I'm just going to pass this constant to pan camera to player method. And now let's try it. And now it pans a little bit faster, so it looks better. Okay, then the next thing what we are going to solve is, of course, add camera boundaries, so the camera will not go past this left side of the level. So for that we are going back to this pan camera to player function, or method, and I'm just going to add one more command here. So here we are also going to set the camera's position, but now we are going to use this arcade.camera.grips constrain xy. So let me hover over with the mouse, and this needs a camera data and also a rectangle. We already passed the camera data, so using cell.camera.viewData, and we have to create these camera bounds. I'm just going to scroll up, and here in the init method of the game view, I'm going to create here the camera bounce. For this, we will need two variables, which will be the max x and the max y. And the max x will be the grid pixel size, which is 70. Each of those tiles are 70 by 70. So 70 times the cell.level1.width. And the level 1 width is 30. So this value, the max x, will be equal to 70 times 30, so 2100. And the max y will be equal to grid pixel size, so 70 times cell.level1.height. So the level 1.height is 10, so 70 times 10, which is 700. And now let's create a rectangle, and this will be the camera bounce. So cell.camera bounce equals arcade.lrbt, and this is the left, right, bottom and top, and this will create a rectangle. So if I hover over with my mouse, as you can see, left, right, bottom, top, and it returns a rectangle. And the left value will be set to Windows width divided by 2, so 1280 divided by 2. The right value will be equal to max x minus the Windows width divided by 2. The bottom will be cell.windows height divided by 2, and the top will be max y. Okay, so now we are using this cell.camera bounce here in the pan camera to player. And now let me run it. And now as you can see, the camera doesn't go outside of the level, playing level. I can move Greeny also to the right side, and the camera stops scrolling exactly at the right boundary. And also on the vertical axis, it doesn't follows Greeny when Greeny goes outside on the bottom, and also when Greeny goes outside of the top, it just stops scrolling at this level. If you want to learn more about the camera system in Arcade, there are many properties and many functionalities. You can just check out the documentation and also the examples in Arcade's documentation. And at the end of this episode, I'm just going to add one more thing to this onDraw method, a debug draw for the camera. I'm just going to create a rectangle called camera rectangle. So camera rectangle will be equal to arcade.lrbt, so left, right, bottom, top, and the left will be this value, so green is sprite.centerx minus the cell.camera position.x divided by 2, and the right side of this rectangle will be this value. So here we are subtracting, here we are adding, and also for the bottom we are subtracting from green sprite center y minus camera position y divided by 2, and here we are adding the same. And I'm just going to draw here a rectangle using this rectangle. So arcade.draw rectangle outline, giving it the camera rect we just created here, and it will be colored white, and the border width will be set to 4 pixels. And now we will see the camera rectangle around Greeny, so how it looks like. So this can be used only for debugging purposes.